Hello everyone. So welcome back to our channel. So this is the third video of Snowflake basic tutorial series. So today we are going to talk about the architecture and key concept of Snowflake, right? So the first thing in architecture, you have to understand what is the introduction, right? Basically. So what is Snowflake? Snowflake is nothing but a fully managed cloud data platform known for its scalability, simplicity and flexibility. Okay, it is designed in such a way that it supports all the public clouds. That means all the major cloud providers, right? Your Azure, then AWS or Google Cloud, it supports, right? So unlike traditional data warehouses, Snowflake uses a unique architecture that separates the storage from compute. Okay, this separation allows basically organizations to easily scale resources up or down based on their needs. But there are more to this, right? Basically, so let's just break it down. So let's first bring the architecture diagram here, right? So this is the architecture diagram. So you can see this is the key section. You have database storage, you have processing unit, and you have cloud metadata service layer. So these three units combines your Snowflake. Okay, so the first one, Snowflake architecture, basically has three main component: storage layer, compute layer, and service layer. Now let's look at each of that, right? So storage layer, what it does basically, so it is responsible for your data storage, and Snowflake uses a columnar format. First thing, it uses a columnar format and a compressed format. So these are the key things we need to remember. First one is columnar, second one is compressed format, right? And it used to store structured data, semi-structured data, as well as unstructured data, right? It's designed to store massive amount of data which can be automatically compressed to save the space. Okay, so one key feature here in Snowflake is that its ability to handle both structured data as well as semi-structured data, let's say XML or JSON, like tables, right? uh, so this is one of the key basically what can I say, benefit of using Snowflake as a data warehouse. So it has the flexibility to successfully, handle both the structured data, that means your tabular format, as well as your semi-structured data, that means your JSON, Avro, Parquet, all those data formats, right? So next one is your compute layer. So in compute layer, what we have to understand that it is also known as virtual warehouse. So this portion is your compute layer. So virtual warehouse, so each virtual warehouse is nothing but a compute cluster that processes your queries independently. So no, when you hit a query in Snowflake, these virtual warehouses are the machines basically that does the processing. So you can spin up as many virtual machines basically, or your virtual warehouses as needed, and you can also adjust the sizes, that means the vertical memory of these virtual warehouses on a single click. No, since your compute and storage are completely separate, that means you can scale your compute resources as well as your storage resources independently. So this is a fantastic architecture basically, right? To handle a variety of workload, right? Why? If you see a big analytical job, right? So you can scale up the warehouse, right? And at the same time, you can also scale it down once your processing is done or finished, right? And then you can turn it off, and you can save a lot of cost there, right? So you see, you understand that your job requires a good analytical load, so you just increase the warehouse size. So let's say you are right now doing a small size, then you can increase it to large or extra large, and once the job is finished, you can simply back it to normal, right? And the final layer, as you can see, it is your cloud metadata service layer, which is responsible for your authentication and access control, then optimization of the queries, security, metadata management, and infrastructure management. So these are the five key points that this cloud service layer handles. Okay, now what are the key benefits of this architecture? As you can see, we'll also look into the document, right, once we'll close this. So the key benefit here is, first one is scalability. Why? Because it separates storage from compute. So you don't only have to understand the jargons, but you have to understand the meaning, or why anyone is saying this, right? So why scalability for Snowflake? Because you can scale either storage or compute independently, right? That means if you want to do much computation, you don't have to pay for higher storage. If you want to do much storing of data, basically, and you don't want to just you don't want to spend a penny on the processing, you can also do that, right? Because your storage and compute are independent. Now second one is your concurrency handling, right? Next, so Snowflakes has a multi-cluster architecture. That means it lets your multiple virtual warehouses access the same data simultaneously without any conflict or downtime. So it is very much efficient if you have different teams in your organization, let's say a engineering team, data science team, or some other verticals team that are accessing same database simultaneously. So it will provide the data to all of the teams at the same time simultaneously without having a downtime. And the third one is your flexibility. So why it is flexible? Because it supports a wide range of data types, right? So either you are working with structured data, let's say CSV or Excel, or you are supporting semi-structured data, let's say JSON or Avro or Parquet. Both things are supported in Snowflake, so you can just ingest, load, process, and publish. All right. Now let's just understand this concept with a real world example. Let's say you are a retail company that handles a lot of daily transactions, customer informations, website activities. So what you can do, you can use Snowflake. By using Snowflake, you can store all the structured and semi-structured data in a single place. Okay, then you can use a small warehouse, let's say of extra small size, to process customer activity data. Okay, as I'm assuming you are a new company, so your daily to daily customer volume will be very less. Then you can use one larger one to run some complex reports, and even more cluster to power your recommendation engines. So if you have recommendation running in your retail website, you can use Snowflake's multi-cluster architecture to power the recommendation engine. And each team, let's say, has its own warehouse for computation purpose, so that teams can work independently as well as simultaneously without giving a second thought for your concurrency or access issue, right? So this is a real-time example how Snowflake helps organization to grow with cloud data architecture, right? So yeah, that's it for this video, and two or three things I will try to say and just close up here. That in architecture, what things you have to remember, basically these three layers: processing, data storage, and cloud service. In cloud service, these 5 points you have to remember: that it supports authentication, infrastructure, metadata, query parsing and optimization, access control. Okay, and the second one, in processing, you have to understand that it's each virtual warehouse is nothing but a MPP compute cluster. That means parallel processing can be done in your computation or compute clusters, basically. And in storage, you have to understand the first two things that we have just discussed, right? It's columnar and it's compressed always. Okay, so this is the three things that basically three components of your Snowflake architecture. I hope you have understood what's the key architecture of Snowflake. Overall, in the next videos, we'll go dig deeper in Snowflake, and we'll try to do more hands-on than talking. Thank you.